A loop of wire of the mass 12 kilograms is going to go through this roller coaster and enter a magnetic field. The loop of wire is 3 by 2 meters and it's starting at a height of 10 meters and the magnetic field is 5 meters in the air. It's going to go through loop-de-loop. But nobody cares about that because we're not calculating anything from loop-de-loop. We are calculating the magnitude and direction of the current. Equations that come to mind regarding magnetism and current are these. F equals PQV, F equals Bill, and EMF is equal to BLV. We don't want these equations because they are about force, and we don't care about force. We're not trying to find force, and we haven't been given force, and we can't calculate them. We're going to use this equation. E is also equal to IR, so we know that IR is equal to BLV. We have B, we have L, and we have R. So if we can find V, then we can plug it in to calculate the current.
Okay, so as Courtney explained earlier, we are going to use the equation IR equals BLV. In order to do so, we're going to need to know what the velocity is. And in order to do that, we're going to need to obtain that information from these heights and the mass given. In order to do so, I'm going to use the equation MGH
set up on the board up there.
equals
Take a
MGH
look at these different parts of the problem.
plus 1/2
Pause the screen here and look at
MV
them.
squared.
And
Because mass does not matter in
see if
this
you can
particular
solve it
equation,
first.
we are going to cancel out the ends
then I will be back.
and be left with GH, which is gravity height, equals GH, gravity and height, plus
Okay,
1/2
so
V squared. The gravity we're going to use is
part A
9.1
on this problem is asking you for
times the height
magnetic
here, which
field
is 10
strength,
meters,
just like the practice problem that we did earlier.
equals 9.81
See, the
times the height here of 5 meters
magnitude of the magnetic field produced by wire at the
plus
position
1/2
of wire
V
Y.
squared.
VI
So since you're left with the numbers plugged in, you're going to solve through
MG
and eventually get velocity
over L.
equals 9.90 meters per second. You can plug 9.9 into the equation over here
This number that I gave you in the problem, and then plug those in to solve for I.
to solve for I.
So 5
I times the resistance of 100 ohms
10 4
equals 4 Teslas
times I
times the length
equals 5.6
3
times 10 to the negative 3.
times V,
Solve for I
9.9 meters per
there.
second.
And you get that I equals
Solve through,
10.7.
I equals 1.8
amps. And the second part of part other way.
Now that we have the
then it'll
magnitude
be
of
pushed
current,
up.
we're going
Wire
to
Y
find
will
the
be pushed up
direction.
instead
Using the
of
left-hand
falling
rule,
down,
it's going
and
to
it'll
the
stay
right.
equilibrium.
That's its velocity. The field
now
is
for part
going
E,
into the
it says with
page,
wire Y
then the
still above
current is
wire
going
X,
counterclockwise.
the circuit is connected. The circuit
Ta-da!
connected to wire